Example 3 on page 425. Find the LCM of x squared plus 2x plus 1. First expression. Second expression, 5x squared minus 5x. And the third expression, x squared minus 1. So this time we're given three expressions, and you're looking for the LCM of these three expressions. So you need to factor out this first expression, and factor out this second expression, and factor out this third expression. Now, let's factor out this, and you learn how to factor trinomial. In the previous, earlier, let's see, x squared plus 2x plus 1. Alright, since this coefficient is 1, right? We don't need to use AC, we don't need to use the, what's it called, ACs or FOIL methods. We can use the normal way we know, which is C, which is A, B, C, right? C is 1. So, we try to find all the factor of C. 1 times 1 is 1. So factor of C is just 1 times 1. Okay? So this is factors of C. Okay? This is sum of factors of C. Remember, our goal is to get the sum of factors of C and make it equal to B equal to, this is B, which is 2. Okay? So we try to factor out C. C is 1, so all you can factor is 1 times 1, or 1 and 1. That's all you have, okay? 1 times 1. So all you have is 1 and 1. The thing about this, on this side, you want to sum up these two factors and make it be equal to, so 1 plus 1 is 2, right? Plus, you know the rule that since C is positive, then the factor of C would have the same sign as B, and side B is positive, okay? That's why you know that these factors have sign positives. No surprise about that. So 1 plus 1 is 2, which is B, right? So you know that the factor of this trinomial is x plus, fill out the factor you have, 1, 1. Okay, simplify. Let me make space. Simplify, you would have x plus 1 times x plus 1. These are two factors of this trinomial. Alright, so we're done with factoring out this first expression. We have two more. How about the second expression? 5x squared equal to, subtract 5x. Alright, we need to factor this out. This is not trinomial, so we just do the normal way. Just factor out what we can. These are common factor, right? So you can factor out 5. And how about x squared and x? You know that you can factor out x, right? Because x is a common factor to both of these factors, x squared and x. So factor out x. 5x times what equal to 5x squared? X, right? Subtracts. Go here. 5x, okay? So 5x times what equal 5x? 5x times what equal this 5x? 1, right? You can double check. 5x times x is 5x squared. Minus 5x times 1 is 5x. So you know that you factor out correctly. Now, look like this is all you can factor out, okay? So factors of this 5x squared minus 5x is 5 times x minus 1. So we're done with second expression. How about this third expression? X squared minus 1. Now, I hope you recall what we learned earlier. We have the formula a squared minus b squared. A squared minus b squared is equal to, when you see minus, a squared, b squared, okay, on both sides the minus, you know that you can factor this out to a minus b times a plus b, okay? What we got is x squared minus 1. You know that 1 squared is 1, right? So actually we have, what we're given right here, the expression is in this form, so that means we can factor out this expression to the two factors. Alright, let's rewrite this as x squared minus 1 squared. So now we have exactly at this format, right? X squared, a squared, minus 1 squared, b squared. So I'm going to use this formula right here. So a is x, right? A squared, x squared. So a is x. So a is x minus b. What is b? 1 squared, b squared. After the minus, right? So b is 1. X minus 1. A plus b. We know a is x, right? So x plus, go here, plus b, which is 1. So this third expression, x squared minus 1, can be factored out to x minus 1 times x plus 1. Alright, now we're done with factoring out all these three expressions. We need to find LCM. Again, to find the LCM, you use factors from these three expressions. You use the factor with the highest, okay, with the highest degree. So, let's see. Just look at the color. For this first expression, right, just look at this one. This is factor of x squared plus 2x plus 1. For this, then look at this one. For this, look at this one. Okay? So I'm going to look at these three boxes and locate or find factors. So for this first one, alright, let's look for the coefficient, a constant, okay, a coefficient first. This one has coefficient 1, so we don't need to write it. How about this one? 5 right here, right? So there's a coefficient 5. How about this one? Its coefficient is 1, so 1 is just 1. We don't need to list it out. So LCM, let me make more space. So LCM is equal to 5. Okay, you can write 1 you want, but 5 times 1 is 5. Okay, because we list out all the factors. Okay, so you don't need to list out. Again, 1 is the coefficient of this first expression, and 1 is also the coefficient of this expression. We don't need to list it out because 1 times 5 is 5, okay? And 5 is the coefficient of this second expression. Okay, now we're done with the coefficient. So let's look at different factors with the highest degree. X plus 1, look at this one. This is also x plus 1. So actually x plus 1 squared, or x plus 1 raised to the second powers, because it happened twice. Now, is there x plus 1 in the second expression? No. Is there x plus 1 in the third expression? Yes. Now, the x plus 1 factors happen twice in this first expression. The x plus 1 happened 1 time in this third expression, okay? The x plus 1 does not occur in this second factor, so only the first and the third. So I'm going to write x plus 1. And remember, LCM used the highest, the factor with the highest degrees. So look like we're going to use the x plus 1 from the first expression, right? Because it happened twice. So I'm going to put to the second power. Alright, so we're done with the x plus 1. Basically, we're done with the first expression, because in the first expression, it's only have x plus 1, so you're done. You don't need to look at this first expression anymore. We used all its factors already. How about the second expression? It has x, right? Now, this x happened 1 time. You need to see if x happened in other factors. You're done with this, right? Because there's no x. You're done with the first expression, there's no x. How about the third expression? Is there x? No. So it's only x, right? X only happened 1 time in this second expression. So you write x. You don't need to include the power because the power is the first power, meaning it only happened 1 time. So x, the first power, is x. So we're done with x plus 1. We're done with x, okay? So we need to look at x minus 1. So x minus 1 happened in this second expression. There's no x minus 1 here. This x minus 1 happened one time because, right, the first power, right, it's happened one time. Now let's check if this x minus 1 happened in the third expression. Yes, it happened here, right? So x minus 1, x minus 1. How many times did it happen? In each expression, x minus 1 only happened one time. In this second expression, x minus 1 happens one time in the third expression. So all you need is x minus 1 to the first power, okay? I'm not going to write this because it's only happened one time, okay? All right, now we have phi, we have x plus 1 squared, we have x minus 1. Now let's double check if we actually include all factors in these three expressions. We include phi constant, so there's no phi here. Yep, there's phi here. Okay, good. So phi is good. How about this one, x plus 1? Is there x plus 1? Yes, there's x plus 1. There's plus 1. X. Is it x? Yes. How about x minus 1? Yes. Okay. Now, or check this way too, to see if you include all the factors here. So x plus 1, there x plus 1, right? X, there x. X minus 1, yep, there x minus 1. There is x minus 1, there is x plus 1. The reason I'm checking on this side because I don't want to leave out any factor here, okay? I don't want, if there are more factor, different, okay, factor, make sure you include it here as well. All right, so let's simplify and we'll finish. Let's see, this is example 3. I want to see how they write the answer. So look like in the book, they want to leave the answer with all term factor out. So let me rewrite this as phi x. I'm just regrouping, okay? So phi with x together. Okay, this phi x, go here. This x plus 1, because it happened twice. So let's list out x plus 1 times x plus 1 twice. So we're done with this term, this term. Remaining is x minus 1. Okay, so let's see. So this is the answer for example 3, which is the LCD. This is the LCD for these three terms. So yeah, this is the LCD for these three expressions, 1, 2, and 3.